Okay, so this video is the second half of the multiple choice final review. So we're starting here at number 20. So if I look here, I'm gonna try and figure out which trig ratio to use, and I think that's the trickiest part for most students. So I know this angle right here is 20 degrees, and I know this is 12 and this is x. I don't know anything about this side and I'm not trying to find it, so I would just not even worry about that side. So I need to figure out what these two angles are, or these two sides are, in relationship to this angle. So this 12 is opposite the angle, and this x is the hypotenuse. So if we think of our SOHCAHTOA mnemonic, opposite over hypotenuse is sine. So I know I'm going to use the sine function. So the sine of 20 is equal to opposite, which is 12, over the hypotenuse, which is x. Excuse me. So to try and simplify this, I always have to multiply by whatever is in the denominator. So I'm going to multiply by x on both sides. So x times the sine of 20 equals 12. So then to get x by itself, I'm going to divide by the sine of 20 on both sides. And 12 divided by the sine of 20, I'm going to go ahead and enter that into a calculator. And 12 divided by sine of 20 is equal to 35.1, which is C. And then on number 21, I'm trying to find this side. So I have this angle. 14 is opposite the angle. This x is adjacent to my angle. So opposite and adjacent is tangent. So the tangent of 58 equals opposite, which is 14, over the adjacent, which is x. So I'm going to go ahead and multiply by x on both sides. So x times the tangent of 58 equals 14. And then to get x by itself, I divide by the tangent of 58 on both sides. So 14 divided by the tangent of 58 comes out to 8.7, which is C. So these last two for this page, we're trying to find missing angles. So I'm trying to find this angle B right here, which is called theta in this case. So I'm going to look at the two sides I know, and I know the opposite side and the hypotenuse. So again, opposite and hypotenuse is sine right here. So the sine of this angle is equal to the opposite, which is 4.5, over the hypotenuse, which is 7. So then to find what this angle is, if I take the inverse sine of this side, these cancel. So I just have my angle all by itself, but that means I have to do that to both sides. So I'm going to go ahead and do the inverse sine on my calculator of 4.5 divided by 7, which comes out to about 40 degrees, which is C. 23 is a similar idea, so I'm trying to find this angle. I have opposite and adjacent, which is tangent. So the tangent of this angle is equal to the opposite, which is 12, over the adjacent, which is 15.7. So then I'll take this inverse tangent of both sides, and the inverse tangent of 12 over 15.7 is equal to about 37.4 degrees, which is A. So then I'm going to go ahead and flip to the next page. So we're now going to start talking about similarity, if these triangles are similar or not. So starting on 24, and let me hide answers. So on 24, we have these two triangles, and we've got to figure out whether or not they're similar. So all I know about these triangles are the sides. So I need to see if the sides are the same ratio. So I've got to make sure I use the right side. So the longest side on this triangle is 39, over the longest side on this triangle is 65. And then the middle side on this triangle is 30, the middle side on this triangle is 50, the short side is 24, the short side is 40. So I'm going to go ahead and divide all of these. So 39 divided by 65 is 0.6. 30 divided by 50 is 0.6. 24 divided by 40 is 0.6. So that means all the sides are proportional. So yes, this is similar by side, 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 which is given right here. And this triangle KLM, so FGH, KLM goes in that same order that FGH does. Number 25, I'm trying to figure out if these two triangles are similar, and it looks like at first glance that it only gives me this angle is equal to this angle, which isn't enough. The theorem is angle-angle. I would have to know two angles. But as you might remember from our unit on parallel lines, vertical angles are always parallel to each other, or always congruent to each other, which means these two angles are congruent. So all of a sudden, we know two of our angles are congruent. So these are similar by angle-angle. Our next couple of questions are with our parallel lines. So we're trying to find the measure of each indicated angle. So the first one is this question mark. Well, these two lines are alternate interior angles, and alternate interior angles are congruent. So if this is 78 degrees, this is 78 degrees. And then on 27, we're trying to find this bolded angle. Well, these are vertical angles like we just talked about, which means they're congruent, or they're equal to each other. So we can set them equal to each other and then solve for x. So I'm going to go ahead and add 10 to both sides. So I have 12x plus 20 equals 14x. And then I'll minus 12x from both sides. And 20 is equal to 14 minus 12x, which is 2x. And then I can divide by 2 on both sides, and 20 divided by 2 is 10. So my x is 10. What it's asking for is the bolded angle. So I can go ahead and plug that 10 in for x. So 12 times 10 is 120, plus 10 is 130, which is A. And then 28 is, okay, it's saying, what would this angle need to be if these two lines were parallel? Well, these two angles are what's called corresponding angles, so they're congruent, making this angle 128 degrees. All right, next question is arc length. So arc length is basically whatever my angle is, I'm going to divide that by 360, which is all the degrees in a circle, and then multiply it by the circumference, which is 2 pi r. So on this triangle, I have 225 over 360 times 2 times pi times the radius, which is 8. So if I put that in a calculator, it comes out with about 31.4. And when I give you your test, I will give you each of these in decimal form, but 31.4 is the same thing as 10 pi inches. And then the area of a sector, we still do our angle divided by 360, but then since we're finding area, we multiply that by the area of the circle. So in this case, I have 300 divided by 360 times pi times the radius squared. So if I put that in a calculator, I have 300 divided by 360 times pi times 64, which is about 167.5. And again, just like over here, I will give you that decimal on your test, but just for your knowledge, I will tell you which of these it is. So this 167.5 is the same thing as D. So 31, we're now asked to find circumference of each circle. So the formula for circumference is just 2 pi r. So I'm actually going to do 32 first. So 2 pi r would be 2 times pi times the radius, which is right here, 5.6. So in my calculator, that gives me about 35.2 feet, which is A. And then on 31, I have 2 times pi times, well, this gives me the diameter, and I need the radius. Well, the radius is half the diameter. So 16.4 divided by 2 is 8.2. So if I enter that in my calculator, 8.2 times pi times 2 comes out to about 51.5. Then our next section is asking for the area of each, and I'm actually going to do it backwards again on this one and start with number 34. So the formula for area is pi r squared. So in this case, I have pi times 9.9 squared, because that's my radius. So 9.9 squared times pi comes out to about 307.9, which is A. Now, number 33 gives me the circumference. Well, if you look at your formula for area, it doesn't have a spot for circumference as a spot for radius. But like we just did on the ones above, I know that the circumference is equal to 2 pi r. So 2 pi r equals 50.3. So I'll start by doing 2 times pi is about 6.28 times r equals 50.3. And then I can divide each side by 6.28 to figure out what the radius is. So 50.3 divided by 6.28 is about 8. So my radius is about 8. So now I can plug that into my area formula over here. So 8 squared is 64 times pi comes out to about 201.3. Perfect. So I think we just have a couple left, and they're from one of our more recent units. So we are looking at circles. So this is asking me to find the length of arc LN. Well, the only thing it gives me is this inscribed angle, but I know that the inscribed angle is half the arc. So if I double this, 79 times 2 is 158. So this arc is equal to 158 degrees. And then on 36, this time it wants me to find the inscribed angle, which, like I just talked about, is half of this arc. Well, that means I've got to find this arc first. So I know that the whole circle is 360 degrees. So if this is 112 and this is 108, if I do 360 and subtract 112 and subtract 108, this arc is 140, so this angle has to be half that arc, so this angle is 70, which is C.